This tutorial is about running Kruskal-Wallis test in SPSS. Here's the data set. So we have individual income data from 3 states. So the 3 states are Indiana, Georgia, and California. Because we have the independent groups and we're looking, and the income is the interval ratio data. So we could run one-way ANOVA to compare the differences in income. So for one-way ANOVA, it's a parametric test. So it has the assumption about distribution in the population. And so one of the assumptions is the normality assumption, which assumes that the data for each group for each population, the income will be normal distributed. So and usually if you have a large sample size, like each group has more than 30, and so we'll need to be that much concerned with the normality assumption. We're more be careful is when we have a smaller sample size. So like we have here, we have a small sample size, only like 5 participants for each group. So we're going to check that if the normality assumption is met. So for small sample size, we actually could run a normality test. So what we do, so let's first run a test to see if the data meet the normality assumption. And so we can go to analyze, the descriptive statistics, and explore. And then I'm going to put income in the dependent variable. State is a factor, which is the independent variable. And the test is actually in the plots. So I'm going to just look at the plots. And in this plots here, I don't need to other those plots. So I'm going to run a normality plots. It's actually, I'm only interested in normality tests here. So let's continue and OK, and see what the output looks like. So on output here, we get the normality test for by state. So there's 2 normality tests. One is the Kolmogorov-Smirnov test, and the other is Shapiro Wilk's test. So both tests test the now is that the distribution follows a normal distribution. So we'll just look at Shapiro Wilk's test, since this test is more powerful. And we can see that for Indiana, the income distribution, you see that this is the p-value is less than 5%. So it means that the assumption is not met. Okay, they are not equal. Yeah, the distribution for the sample, not equal to a normal distribution. For Georgia, the distribution is the assumption is met. Yeah, so normal distributed in the population. And for California, it's not met. So California data is very significant different from normal. So based on this, so if we have a smaller sample size, we can run the test. If you have a large sample size, we don't need to run the test. So based on test, we're going to use a non-parametric test for our data. So because when we check the normality test, the income distribution seems to be not normally distributed. Especially you can see that you see there's some outlier here. So what we could do is we can run a non-parametric test. So in this case, we have more than 2 groups. So we're going to look at the Kruskal-Wallis test, which is a non-parametric alternative to one-way ANOVA. So to run the test, there's 2 ways to run the test. First, we'll use this analyze non-parametric test. We use the legacy dialogues, and we'll use this k independent samples because we have more than 2 groups. And then we're going to put income in the test variable box, and then state in the grouping variable. We need to define the range, which is how we code the grouping variable. The minimum is 1, maximum is 3. And by default, Kruskal-Wallis H-test is checked. And we don't need to do anything with the options because we have the rank order data. And so, but we're going to, if this is available, yeah, we are going to use an exact test because we have small sample size. Otherwise, a large sample size, so we can use a asymptotic p-value. So then we're going to continue, and then we're okay. So in the output here, so we will have all the ranks information. So we for the three states, yeah. So basically we rank order and all this data, the income data, from smallest to largest. Yeah. So we can see that for Indiana, this is our average rank, and for just Georgia's average rank, they seem to be similar. And California is quite different; it has a large rank. And then when we run the test, this is the Kruskal-Wallis test, which this is a test statistic, and degree freedom is 2 because we have 3 groups. Yeah, so number groups -1, that's what degree freedom. So the Kruskal-Wallis test, they follow a chi-square distribution. We asked for the exact test. So this is the exact test p-value, which you can see that this is smaller than 5%. So that means there's a significant difference in the ranks. And so between the states, yeah, in their income. So this method does not give us, so we cannot do a follow-up test. We'll see another method running Kruskal-Wallis test. So we're going to use analyze, and then we'll go to a nonparametric test and independent samples. So here in the fields, we're going to put income in the test fields box, state get in the groups, and in the settings, we're going to choose the test is Kruskal-Wallis test. And by default, we can do multiple comparisons if the test comes out significant. I'm going to check others. Those are looking good. So we're going to run this test. And when we run the test, we get a summary for the test, for the hypothesis test. So the hypothesis is we looking at the distribution of income. They say is the same across the different categories, levels of state, categories of state. So this is a test we did, and this is the p-value. So the p-value here, the program gives us the asymptotic p-value, which is that's we got here, this one. Yeah, so from this way of running the test, we cannot, the program didn't get us exact p-value, which is okay. Yeah, so the results are the same. Yeah, we're going to reject the null because p-value is less than 5%. And then this is the test statistic, which is the Kruskal-Wallis H statistic and degree freedom. And this is the p-value, as we mentioned before that. So this is a significant. And so we know that there's a difference in income between the 3 states. So we'll need to do a follow-up test that will help us see it is the differences between which states. So this is a graph that shows the income for each by state, and then we can see that California there's a very there's a high income owner, and then and that's also why when we run the normality test, it comes it's very significant different for California, very significant different from normal distribution. So this is the pairwise comparison following a significant Kruskal-Wallis test, because we have more than 2 groups. So we want to find out between which the groups or the states here, these differences we see here. And so with the pairwise comparisons, and so there's 3 tests was wrong, comparing each group with another group. So first is to compare Georgia with Indiana. So this is their rank differences. And so it's based on the rank here. Yeah, so this is the difference in the rank. And so first one is not significant. P-value is larger than 5%. So there's no difference between Georgia and Indiana. And then when we look at comparing Georgia with California, we do see that there's a significant difference. And so then when we compare Indiana with California, there is also the difference. But we'll be careful. We need to actually look at adjusted significance because this is adjusted by Bonferroni correction. And so because we are running multiple tests, so we need to look at adjusted sig column to keep our type 1 error rate is at 5%. So if we look at the adjusted, the Bonferroni corrected p-value, there's only significant, there's one comparison significant difference, which is between Georgia and California. Yeah, so this is significant difference. And the mean rank, the difference is 7.2 here. And there's also a nice graph that shows the pairwise comparison, and which so the blue here is significant, while the green is non-significant. And we can see that this is California with their mean rank, average rank, and Indiana's average rank, and Georgia average rank. So there's no difference here. There's also no difference here, but difference is between Georgia and California. And so that's this is how we run the Kruskal Wallis test in SPSS. Thanks for watching it.